Scientists fear we may be heading for a huge extinction in the seas, with many creatures threatened as carbon dioxide makes the oceans increasingly acidic. Now on BBC World News, Roger Harrabin finds out for Our World.
The oceans are the cradle of life. Creatures great and small, nurtured in the stable chemistry of seawater, almost unchanged for hundreds of thousands of years. But with all the carbon dioxide from modern society, it's changing now.
You can't see it, but the carbon dioxide from our cars, homes and factories is dissolving into the seawater. Now, carbon dioxide's an acidic gas, so that's turning seawater more acidic. Humans are changing the chemistry of the oceans.
Many species will be threatened as carbon dioxide makes the oceans increasingly acidic. Some may already have been harmed. Scientists fear we could be heading for a huge extinction in the seas.
I think it's fair to say that the scientific community are very worried because we really see a major shift in the ocean ecosystem.
The implications are vast. Billions of people depend on the seas for their food. So how will sea life cope in the more acidic oceans of the future? I travelled to the Mediterranean for clues. The volcano Vesuvius looms over the Bay of Naples. The island of Ischia is volcanic too. That's our destination. They set off fireworks when we arrived to celebrate the anniversary of the island's patron saint. On Ischia, the Earth is still producing pyrotechnics of its own. Scientists like Jason Hall Spencer are drawn here to study the sea, which is made naturally more acidic by volcanic activity.
Yeah, completely clean. The carbon dioxide is turning the water here much more acidic. And scientists say that the conditions down here resemble very much the conditions that we may be seeing through all our oceans by the end of the century. So we're going to take a look.
This is Dr. Hall Spencer's own film of his underwater experiments. The more acidic conditions here clearly favour species like this seagrass. It's possibly the tallest seagrass in the world. It appears to have been hyper-fertilised by the extra CO2 bubbling from the volcanic vents. The scientists are worried by what's not here. It looks as though the extra acidity is toxic to all creatures which make shells, a large part of the ocean food chain. The shells of these snails are supposed to be brown. They've been stripped to a brittle mother of pearl by the more acidic water. Dr. Hall Spencer says this should worry us all.
Under the water there's loads and loads of bubbles coming up from the seabed that are carbon dioxide acidifying the water. And what we're doing is first of all finding out how many bubbles are coming up, how much CO2 is affecting the chemistry of the water, and seeing what it's doing to the pH or the acidity of the water. While we're doing that, we're basically laying down plastic bags on the seabed, collecting the gas as it bubbles up, and analysing the gas to see if it is CO2, which we've proved that it is.
Tell us about the seagrass that we're seeing on this video.
It's growing really well, and it's basically because it's losing its competitors and being fertilised by the carbon dioxide.
And other creatures, though, are doing very badly, some of them.
Yeah, it's almost a false view you're getting, because although the seabed looks healthy with all this grass there, it's almost like a monoculture. You've hardly got any diversity of organisms there. The whole ecosystem has been weakened by this removal of the shelled organisms.
So we're on land now, and we've brought up some of the creatures that Jason's got for us. This is a normal shell. This is a shell that Jason picked up from the bottom of the sea here, obviously completely different. Can you explain to us, Jason, what's going on here?
Well, yeah, this is a shell that's strong and living under normally easy to calcify conditions, which we've got now. But this is an indication of what it's going to be like in 50 years from now, because this shell is dissolved. It's being dissolved because of the acidity of the water. It's so thin you can push your finger through it. And that's not good news for marine life in general. There's limpets here as well that's showing exactly the same pattern. So a normal limpet's got a strong shell. Every schoolboy knows it's so strong you can't push your finger through it. This one is so weak, I've got to be careful when I'm holding it.
It's like mother of pearl almost.
Yeah. The shell is really, really thin in comparison to what it should be, and that's due to the acidity of the water.
And this acidity level you're measuring down there, how does it compare with acidity levels of the future that we expect from the pollution that we're putting into the ocean that will affect oceans around the world?
Well, this is a look at conditions in 50 years from now. Okay? That's a worry, isn't it? Because all of these organisms that make shells, corals included, will dissolve.
We can't be sure future oceans will look like this. Levels of acidity here fluctuate with the currents, whilst future seas will be uniformly more acidic. It's a new branch of science, and researchers are still finding their way. But they're very concerned about what our pollution will do. Much of the CO2 from industrial society gets absorbed into surface waters. It turns the top of the ocean more acidic. Some of the CO2 is taken up by tiny plants. They die, sink, and increase acidity in the deep ocean. Sometimes that deep water wells up, making surface water more acidic still. Just how acidic will oceans become? Studies vary, but results from research ships like this one in Bermuda suggest that acidity has increased about a third since the Industrial Revolution. Recent research showed the shell weight of tiny creatures at the bottom of the food chain called foraminifera had decreased over the same time. Scientists running the Bermuda research were sceptical, but now they're convinced that pollution is to blame.
Based on our data, the pH is changing. It was stable for a very long time, and it's changing now. And you know, the CO2 can only come from one place, and that's the atmosphere. And we know that the CO2 is increasing in the atmosphere because of man-made emissions. I mean, 7 billion tons a year is going into the atmosphere. It has to migrate into the oceans. It always has.
And as pollution increases throughout the century, so ocean acidity is forecast to rise.
Perhaps by the middle of the century, we'd maybe see a 60 to 80% increase in the acidity of the oceans. And by this end of the century, we could see as much as 150 to 200% increase in the acidity of the oceans.
So what's the fate of our seas 100 years from now? It's creatures like mussels forming alkaline shells which are vulnerable to acidifying waters. This is the River Exe in the west of England. Scientists like Dr. Steve Widdicombe know just how much of the marine ecosystem depends on creatures which form shells. Some of them are a real surprise.
For example, have a look at this. We just have one of the mussels, and on this mussel we have a limpet. We have material which looks at first glance to be a plant, but that's actually an animal as well. And turn it over and we have a barnacle. Now, we're extremely worried about all these animals because they're going to find it very difficult to build their shells in the face of ocean acidification.
For now, it's the mussels which are focusing the scientists' attention. They're economically valuable. They feed us. They feed the fish that we eat. They also perform the useful function of filtering seawater. Will they be able to survive the levels of acidity this century? At nearby Plymouth Marine Laboratory, tests suggest that some shell-forming species won't last until 2100. Tests involving taking the blood of mussels have shown their immune systems are damaged by greater acidity.
Oh, we should be extremely worried about ocean acidification. The wide and varied effects that ocean acidification is having on marine animals has huge implications for the health of our oceans and also the productivity of our seas.
The other CO2 problem is what they're calling ocean acidification. On top of climate change, of course.
Are we having them round like that, or are we having them flat?
It's a message the children at Ridgeway School in Plymouth are trying to get into the heads of the adults who ruled the world.
This is serious. It's really important. The seas all over the world are becoming more acidic. It will affect everyone and everything in the sea, and is a lot more important than your stupid soap.
An animation from the children was presented to a big science congress in Copenhagen recently. The chair of the panel said their voices were more eloquent than anything she could say.